Welcome to Two Projects. In this video, we are going to explain about a project titled DFR-TSD, a deep learning-based framework for robust traffic sign detection under challenging weather conditions. So now coming to the introduction part, DFR-TSD, short for Deep Learning-Based Framework for Resilient Traffic Sign Detection in Harsh Weather Conditions, stands as an innovative milestone in the field of computer vision and intelligent transportation systems. Detecting traffic signs is a vital element of autonomous driving, advanced driver assistance systems, and the broader landscape of road safety. Nevertheless, the undertaking becomes exceptionally demanding when confronted from adverse weather conditions like rainfall, fog, or snow. So now coming to the objective part for this project, the main purpose of DFR-TSD are as follows. Sturdy traffic sign detection. The core objective of DFR-TSD is to attain resilient and dependable traffic sign detection even in unfavorable weather conditions. Secondly, we have improved road safety. Ensuring road safety is a top priority, and precise recognition of traffic signs is a crucial element in achieving these goals. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and cpon for visualization are important. Second, here we have exploring the dataset. This involves reading and plotting images to understand the dataset visually. Then we have image processing, converting images to a blob object, defining classes for objects, declaring bounding boxes for object localization, converting image arrays to NumPy arrays, and loading the pre-trained model. In this, reading the network layers and configurations, extracting the output layers, deploying the YOLO You Only Look Once model, which is a deep learning algorithm for the real-time object detection. The next here we have image processing, appending the image annotation file and images for further analysis, converting the image from BGR, that is blue, green, red, to RGB color space, creating a mask and resizing the image. So here in this, data augmentation, applying various data augmentation techniques such as randomizing, rotating, and transforming the images to increase model robustness. The next here we have loading the YOLO PyTorch. Loading the PyTorch based implementation of YOLO, a popular object detection model. Next here we have installing the packages required for YOLO v5 in Colab. Installing the necessary Python packages for running YOLO v5 in a Colab environment. Then we have processing the data based on the YOLO v5 model. Pre-processing the data according to the YOLO v5 model's requirement, which will include image resizing, format conversion, and normalization. Then we have building the model in Colab. Building various object detection models including YOLO v5, YOLO v8, YOLO v3, FASTA RCNN, CNN, VGG, or other models in a Colab environment. Next here we have training the model. Training the object detection model on the pre-processed data to learn to detect the objects within the images. Then we have building the model with YOLO v5. Creating a model using the YOLO v5 architecture, a popular choice for real-time object detection. Next here we have Flask framework with SQLite for sign up and sign in. Developing a web application using the Flask framework and using an SQLite database for user registration and authentication. Next we have user gives input as image. User provides input in the form of the images for an object detection. Next here we have the given input is pre-processed and with trained model is used for detecting. So here in this, the pre-processing the user provided image and utilizing the trained objects detection model to identify objects within the image. Next here we have the segmented each object and put bounding box. Drawing bounding boxes around the detected objects to highlight their positions within the image. And the last one here we have final outcome is displayed. Displaying the results of the object detection, often showing the image with objects outlined by bounding boxes. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Another folder named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Then here we have .ipynb file, which is a Jupyter notebook file which contains a combination of 4 graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and the space path over here, and now hit the enter button. Now type python app.py and now just hit the add the button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. And I'm using Chrome. Just paste the link over here and now hit the enter button. So this is our home page for the DFTSC. This is showing about the YOLO V5 object detection. Here you can see that there is a button for sign up. Just click on this button and enter your username, your name, email ID, phone number and your password over here for doing the registration. I have already done the registration, so I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration and simply click on login button. So here by scrolling down below, here you can see that there is a button for choose file. Let's click on this button and upload the image. So let me just open that folder for uploading the image. So here you can see that from all these images here I am choosing suppose second image, and now click on open button and here click on upload. So you can see that it is detecting as this that this is the pedestrian crossing, no stopping and roundabout 0.71. Let's try with some other image. Click on choose file and suppose that I am choosing this image. Click on open button, click on upload. It is detecting as this is a pedestrian crossing and this is the speed limit. So depending upon the image you are providing over there, it will detect about this. Here you can see that there is a button for about. Just click on this button and here you can see that there are many different graphs, and based upon this graph we have used many different algorithms for calculating the accuracy, precision, recall. Here is a button for sign out. By simply clicking on this button you can successfully log out with this. Coming back to the conclusion part. In summary, the deep learning based framework for resilient traffic sign detection in harsh weather conditions known as DFRTSD is on the verge of bringing about a substantial transformation in the fields of intelligent transportation systems and autonomous driving. It presents a hopeful remedy to one of the most critical dilemmas encountered by automated vehicles and advanced driver assistance systems: the dependable identification of the traffic signs in unfavorable weather conditions. So here we have completed with our project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.